Okay, hello guys. Today is our second lesson for the IGCSE physics that is about force, momentum, and impulse. Okay, so here's our today's content. You can find here. The first part is about resultant force and Newton's three laws. And the second part is about classical forces. And third part is about momentum and impulse. Last part is momentum conservation. So maybe you're very familiar with the word force, but I guess you're not very familiar with momentum and impulse, right? Because they are just appears in the IGCSE physics. Okay. Today, let's have a full discussion about these forces and maybe momentum and impulse and to find how we can use them in our IGCSE test. Okay. So let's move into the first slide. Okay. So here, let's have a discussion about what is resultant force. As you learned this chapter before, I guess you have learned about something about force, right? That force is a very important discussion made by Newton, right? We always combined Newton and force. We also think he is a force's father, right? Okay, so Newton investigated many laws and maybe some like definition about force. So to remind him, we use Newton N to represent for force, and we use a capital letter F to represent what is force. Okay, here's unit, and here's how we describe force. Okay, so here is the first few part you need to know about this. Okay, and here you can find in the two figures, the first figure, here are two forces acting on a body, right? Here is a ball, and one force is to the right and is 5 Newton, and another force is 3 Newton on the left. Okay. And then maybe we can make an addition with the two forces. One is 5 Newton, another is 3 Newton. So here we can set 5 Newton plus negative 3 Newton equals to 2 Newton. Okay, here is the force. So we can say that it's a resultant force for the 5 Newton and 3 Newton. Okay, so resultant force is 2 Newton on the right. Okay, and in the second figure, we can find here there are also two forces acting on the car. One is 60 Newton and another is 30 Newton, right? So here you can say 60 Newton plus 30 Newton that equals to 90 Newton to the right. And for the second example, you can find here is the 30 Newton and 10 Newton. So here's the total resultant force is 20 Newton. That is very easy, huh? So maybe let's have some difficulty about, maybe increase some difficulty about these problems, okay? Okay, so in the last slide, we have discussed about the force same direction or they're maybe opposite direction because they are all in the horizontal line, right? Now let's maybe change a little bit about the force's direction. And before that, we have to make a very small example to help you to know what is a vector and how we can make an addition about this, okay? So let's make a very brief leading about a vector part, okay? So imagine you're in a trip. Maybe you're from Singapore to Shanghai, right? Like this, you can take a travel. And if you want to go there very quickly, maybe you can take a plane, right? Maybe you can take the Air Asia, or maybe you can take China Southern Airline to Shanghai. Okay. But if you are a student, you don't have much money to do this. So maybe you can take a transfer flight, right? So you can first traveling from Singapore to Kuala Lumpur, and then take a transfer flight from Kuala Lumpur to Shanghai, right? Because this is two routes. One route is from Singapore to Shanghai, and another route is from Singapore and then to Kuala Lumpur, and then we get to Shanghai, right? Although they are two different routes, but they have the same start point and the terminal point, right? Okay, so here is what we discussed in vectors. So in the angle or in the view of mathematics, we can say that there are the two same routes because they have the same start and the same terminal. Okay, so we can say that in the vectors view, they are the same. So Singapore to Shanghai equals to Singapore first to Kuala Lumpur and then to Shanghai. Okay, this is the same route. Okay, so then if we just use the letter A and B and C to represent for three cities, so we can say just from AC we can use a upper arrow to represent for the vector. and it equals to from A to B, AB's vector plus the vector B to C. Okay, this is what vectors mean right here. Okay, so first you have the vectors and you can make an addition about this. And secondly, you can just use them in the forces. As we know that force is also a vector. So here, let's have a little discussion about the vector's definition, okay? So we can say that vectors means that physical quantities which have the magnitude and the direction. Okay, maybe we said PQ means physical quantity that has a direction and also its magnitude. Okay, so here what vectors means. So just like an arrow, like this way. This is a vector. Okay. So force, it also has a direction and also has its magnitude, right? So we can say force is a vector. So if you now want to add two forces together, and here, maybe there are two forces, right? So right here, they're at the same starting point. There are two vectors or two forces right here. So here, you can just move the arrow below the upper arrow to these places, to the blue arrow places, to form a parallelogram, like this way, okay? Because this is a parallelogram, okay? And you can point your starting point to the terminal right now, like this way, and this is your vector or resultant vector, okay? So why is this? So first we have to know that here we have the first property that force equals to this force because vector means the meaning of the direction and magnitude. So if you have the same magnitude and same the direction because they're parallel lines, right? So they are the same. Okay, so maybe the force 1 plus force 2 can becomes to force 2, sorry, force 1 plus force 3, right? Okay. And the second idea is about that we from the first point and then go to the next city and then go to the terminal just equals to a direct plane, right? They have the same result, okay? So we can say that F1 plus F3 just equals to the purple line or purple vector, like this way, okay? So after that, we can say, oh, here is a resultant vector for the two vectors, okay? This is our discussion of the vectors. Okay, after this, let's moving to the forces part, okay? So we can say that two forces, if you want it to together, you can move one force to another head of the vector, moving one tail to the head of the vector, and then to the other head. So it's just from one tail from the another's head is a total vector, okay? So also for two vectors or three vectors, you can also use in this way to do so. Like here, if you have here is a vector, and here's another vector, and here is a third vector, you can first move the vector like here to these places. And then you can use your pencil to draw like this way, a parallel lines with the second vector, like this way. And then use a blue line to draw them together from the starting point to the terminal. Okay. Right here from the starting point to the terminal, like this way. Okay. After that, you can move in the third vector, like here, to this way. And you have find that blue vector means the first vector added with the second vector. And you can say if we added the blue vector with the third vector, that is the total resultant force for the three forces. Okay, so then you can use maybe a black pen to draw arrow from the starting point to the terminal, like this way. Okay, so there is this black vector. Okay, so I guess here you can understand how we can use this to solve some physical problems. So let's move into our first class lesson here, just to do this problem and try to give me an answer, please. Okay, wait for 1 minute, please. Okay, so let's back to our class. If you didn't finish the problem, you can just pause the video and then try to think more, okay? So here we can find the question is, what is a resultant force for force X and Y? Okay, so here we can find X is an arrow upwards and Y is an upward arrow to the right, right? So if you want them to add together, you can move Y to these places. Just use Y's tail to connect it with X head, right? In this way. So then you can using the laws, you can from the tail of the X to the head of new Y, like this way. Okay, so here because this is a resultant factor, the red arrow means that. Okay, so you can make a comparison with A, B, C, D. You can find maybe D is correct, right? Z is from the left below to the right upward, right? So here we choose D. Okay, so this is a problem. And okay, so here is the first part of our resultant force. Okay, so now you can do some exercises for the past papers of all the resultant force. I guess maybe each 2 year, maybe for 2 years, we have a exercise or like a question like this one. Okay. So the second part is Newton's first law and Newton's second law and about third law. Okay. So first, let's move into the first law. So what is about the fourth law? Okay, many scientists have discussed about this question, and Newton also discussed this question. At the pandemic period, Newton went to his hometown and to do this experiment like this way. Okay. Okay, so he uses some materials on the end of the track, and here is a small toy car, and they are placed on the track. And once you release the car, you can find the car just moving down and then passing through the materials, right? So he changes the materials, like using the tower, using the like wood, he are using also using this maybe the iron or maybe like other things, or maybe using the calcium stone. Okay. Okay, so he has changed many materials. And he find if you change this to like a glasses or like a calcium stone, you can find it can move a very further distance on the materials, right? But if you're choosing the tower or like something not very smooth, the toy car will just stop at these places, maybe here. So at a very little distance, right? So here just has a thinking. So even though we choosing the materials such as glasses and the stone, they are very smooth and they have very less friction force, but they still have friction force, right? So the car must have to slow down. But if we try to imagine that if there is a material that is maybe absolute smooth, there's no friction force, uh, the car can move on it very freely. So maybe it can move a very further distance, or even it doesn't stop, right? So he tried to think it in his mind about the experiment. So if there is no forces acting on the car, or you can say on the horizontal direction, there is no force or resultant force equals to zero. So the car or the toy car can traveling for a very further distance, right? Okay, so the car can travel at a very further distance, okay? Or even doesn't stop. So then we can use another word like had a constant speed v, right? Because once the velocity decreases, maybe here's a like acceleration or deceleration may make the car try to stop, right? So maybe here it has a constant speed, or maybe just stay still in this way, okay? So here we can say that is Newton's first law. Okay. So here there's a very long and boring definition about the first law. You can just remind in this way that if there are no force or resultant force is zero, maybe an object can traveling for a very further distance. Or you can also say here the velocity is a constant and it maybe stay still. Okay. So this is his problem. Okay. Okay, so let's move into the second formula. Like here is about Newton's second law. So what is Newton's second law? We have already discovered what is acceleration, right? So Newton's second law is just discuss about the scientist, discuss with scientists, okay? And they have different experiment. Like they're dragging a car, like this way. He's using a driving force to dragging the car. And you find once you increase your force, the car moves faster or the acceleration increases, okay, like this way. So here you can say that here the resultant force increases that can make the car move faster, right? And also imagine you're dragging a very heavy, maybe like a refrigerator or like a TV, you're moving your house. Okay. So here you can find also it's very hard for you to drag them. Okay, right? Maybe they're moving a very little speed on the ground, right? So also you can find there are two like conditions to restrict the acceleration, right? One is the force. If the force is less, the acceleration must very slow, or it can very small value. Okay, and also for the mass, if the object is very heavy, the acceleration also it maybe declines with acceleration. Okay, so here we can say that is the formula is force equals to mass times acceleration. And also you can use the experiment to prove this. Here you can find in the table, once we apply the 1 Newton resultant force, the x on the mass is 1 kilogram. And here you can find the acceleration is 1 meter per second square. Okay. And also when you apply for about 2 Newton resultant force, here the mass is 2 kilogram and the acceleration here is 1 meter per second square. And the third column is about 4 Newton force. And when you apply a 2 kilogram mass object, and you can find the acceleration here is 2 meter per second square. Okay. And the last column, 6, 2, 3, right? You can find the force always equals to the mass times acceleration, right? So this is the Newton's second law. So you can remind in your mind that the resultant force equals to just mass times acceleration in this way. Okay? So this is Newton's second law. Okay. And try to look here at Newton's third law. So what is the third law? And you can find in the figure that maybe a boxer is maybe he's a training, right? So he just makes his fist punch on the apparatus, right? And he finds there if he applies the force on the apparatus, and the apparatus also will give him a reaction force, right? So here you can find this action and reaction. And they're in the same magnitude, but they're in the different direction or opposite direction, right? So this is very easy. We can say that Newton's third law means the action force equals to reaction force. And it only happens in the two objects. There's no the third object, right? So we can say action force or magnitude of action equals to reaction. And we can also say that they have the opposite direction. Okay, so there are the Newton's third law. Okay, so after this, let's doing a very small question in this problem 2, please. Okay. So just try to use the way we have discussed before, like the Newton's 3 laws, and try to solve the problem. Okay. Okay. So in this problem, is that an object falls towards the surface of the Earth. The object is falling at its terminal velocity, and which statement is correct? So maybe here, maybe you have some difficulty with terminal in this word. I mean, you doesn't know what is the accurate meaning, right? So maybe in our daily life, we see terminal at the most time, maybe in the airport, right? You can find it is terminal 1, terminal 2, and terminal 3 when you want to travel into other countries or want to just traveling like inland. You can say that the terminal means the airport of the total city, right? So terminal also means the maybe the final places we went to or just we landed in, we can say this is a terminal, right? So you can also use final to represent for terminal. It's this way, okay? So it is a final velocity, okay? So once it reaches to terminal velocity, that we can say maybe the velocity doesn't change anymore, right? Because once it change, maybe the change of the velocity is a new velocity. So we cannot say that the velocity is a terminal, right? So it must stay still, and that we can call it a terminal velocity, okay? So here is the question, it is what statement is correct? So here we can say if the object falls to the Earth, maybe it will experience two forces on its way, right? But there must an air resistance force to make a balance with it. Because according to Newton's first law, that we had resultant force is zero, or there's no forces acting on the body, that makes the object to a terminal velocity, or it has no stay still, right? No motion, okay? So here it must be a air resistance force to balance with weight, okay? And they're in the same magnitude and different direction, okay? So here we can say that there must be an air resistance force. We can only choose in A and B, and the acceleration of the object is zero, right? Because there's resultant force is zero. So according to Newton's second law, we can set resultant force is zero. So here, acceleration also can be zero, okay? Because mass cannot be zero. Only acceleration can equal to zero. So here, finally, we choose B. Okay, so please just try to rethink of this question by using the Newton's first law and second law. Okay. So here is today's our lesson. Let's move into the second part. Okay.